So welcome back to AP Calc. Today's topic would be finally 4.5 part 1. So to solve related rate problems, you need a strategy that always works. Related rate problems always can be recognized by the words increasing, decreasing, growing, shrinking, and changing, right? So follow these guidelines in solving a related rates problem. So step 1, make a sketch, label all sides in terms of variables, even if you're given the actual values of the sides. Write down the sides and the rates that are given, write down the rate you are trying to find, and then find the equation that ties your variables together. If the problem mentions area, you will most likely write an area formula. If the problem mentions volume, you will most likely write a volume formula. If the problem mentions lengths of sides and figure is a right triangle, you most likely will use a Pythagorean theorem as your equation. If the problem mentions angles, measures, and the figure is a right triangle, you will most likely use a trigonometric ratio as your equation. And then step 4, you may now plug in your constant into your equation. Never plug in any variable into your equation until after the derivative is taken, all right? So make sure that you guys leave the variable until you take the derivative, because you might think that's a constant and then you might accidentally just eliminate it. So differentiate your equation with respect to time. Remember, you are implicitly differentiating with respect to t. So every time you guys take the derivative of x or whatever, right, you're going over dt. So you always want to attach the d whatever you're trying to find. So plug in the variable quantities mentioned in the given and when parts of the problem. Hopefully you will be able to, you will know all the variables except for one. If not, you will need an equation, which we will solve for unknown variables. Sometimes this will require using the same equation as the one you used above. Do this work off the side. So label your answers in terms of the correct units, very important, and be sure you answer the question asked. So example 6 says an oil tanker spill. So an oil tanker spill spills oil that spreads in a circular pattern whose radius increases at a rate of 50 feet per minute. How fast are both the circumference and the area of the spill increasing when the radius of the spill is 20 feet? So again, step 1, right? So we want to draw a picture. So we know we have an oil spill in a circular pattern, right? And then they tell us the radius, right? We have a radius. And then they're also telling us it's changing, right? So the given, let's look at the given first. In this case, they're telling us that the radius increases at a rate of 50 feet per minute. So we can call that dr dt equals 50 feet per minute, all right? And then what we're trying to find, which in this case, right, we need to find how fast, right, the thing that makes it a related rate problem, like I said, the word increases, right? So that means it involves something, and in this case, it involves two things. It involves circumference and area of a circle. So here we need to find both how fast the area is changing, the ADT, and how fast the circumference is changing, dCdt. All right. And then the formulas we're going to be using to find that. So pretty much, right? So the formulas. So you guys should know by now the area of a circle is pi r squared. So area equals 2 pi r squared. And of course, circumference is equal to 2 pi r. So let's first do the area. Do it in orange. So the area, it says dAdt. So dAdt, take the derivative of that implicitly, equals pi, well, 2 pi r times dr dt. And then here we do the substitution. So that'd be 2 pi times r, which in this moment is 20 feet. So times 20, and then dr dt, which is 50. So we can say that dAdt equals 2 times 20, which is 40, times 50 would be 40 times 50, which in this case is 2,000 square feet per minute. All right, and then we want to figure out how fast the circumference is changing. So in this case, we're going to say dc dt, right? So let's look at that one right there. So dc dt equals 2 pi r. Forgot a pi here. So to get rid of that, we end up with just 2 pi times dr dt. And that's going to be equal to 100 feet per minute, right? So we can say that the area is changing. Area is changing at area changes at a rate of 2,000 square feet per minute. And the circumference changes at a rate of 100 feet per minute, right? In both cases, is pretty much when at r equals 20 feet at r equals 20 feet. All right. So example 7, falling ladder. So Trevor's paying a late night visit to his girlfriend, Michaela, in hopes of sneaking her out of the house after curfew. He brings a 25-foot ladder and leans it against the side of the house in order to climb to her window. Soon after Trevor reaches the top of the ladder, Michaela's father pulls it into the driveway, rushes to the ladder, and begins to pull its lower end away from the house at a rate of 2 feet per second. How fast is Trevor plummeting to the ground if he continues to hang the top of the ladder at an instant the bottom of the ladder is 7 feet from the house? All right. So they're telling us pretty much, so we have if you guys haven't noticed yet, it's a right triangle. So the given, right, we know it's a related rate problem against something's changing, right? In this case, they're pulling away the ladder from the house. So he brings a 20-foot. So we know the hypotenuse is equal to 25. That remains a constant, right? 25 feet. And then in this case, we can call it dx dt, right? And then this is going to be just r. So we're going to say dx dt is changing at a rate of negative 2 feet, right? Because it's pulling away from the house per second. And then we want to find, right? We want to find dr dt. How fast is he falling when, right? When the ladder is 7 feet from the house, when x is equal to 7 feet. So we need to find dr dt. In order to do that, we're pretty much going to have to use Pythagorean theorem, right? Because this is pretty much just r. This would be x. So we can say x squared plus r squared equals 25 squared, right? And then here we're going to take the derivative. So that's going to be 2x times dx dt plus 2r times dr dt equals 0, right? Derivative of 25 is 0. So here, again, substitute the values that we know. So that's going to give us 2 times x, which in this case happens to be 7 feet, right? That's how far away it's from the house, times dx dt, which we know it's negative 2. And then plus 2r, 2 times r, which in this case we can figure it out, right? So if it's x squared plus r squared equals 25, you just use Pythagorean theorem. So that's going to be x is 7, so that's going to be 49. 49 plus r squared equals 625. So r squared equals 576. Take the square root of both sides. You get r equals 24. All right. So in this case, r is 24. And then we need to find dr dt, right? So we just leave it there in the meantime. Equals 0. So this is going to give us 14, 28. So negative 28 plus 48 times dr dt equals 0. Again, add 28 to both sides. We get dr dt, 48 times dr dt, or dr dt equals 28 over 48 Divide top and bottom by 4, you get 7 over 12. So we can say that Trevor is falling at a rate of 7 over 12 feet per second. And there we go. That's it. Let's not forget when x equals 7, or the ladder is 7 feet away from the house, right?